So we've been talking about scatter plots and correlation for a little while now. We've been talking about using a scatter plot to determine the strength and the direction of a relationship between two variables. But now we're going to formally define how we can actually mathematically determine both the strength and the direction of a linear relationship between two variables. And we're going to do that using what we call the correlation coefficient, which we usually symbolize with the letter R. We've already talked a little bit about R, but I just wanted to reiterate a few things about it. First of all, R can only have values between -1 and +1. And as you can see from the diagram I have here, values of R that are closer to the ends of this spectrum, either closer to -1 or closer to +1, are considered stronger values of R. Those indicate a stronger linear relationship between your variables. If your value for R is closer towards the middle, closer to 0, that indicates that you have a weak linear relationship between your variables. And then values between 0 and -1, or between 0 and +1, would be in the moderate range. There aren't any hard and fast rules about which ranges correspond to a strong relationship versus a moderate relationship. It just really depends on what data you're looking at and what your purposes are. But just keep in mind that the closer you are to R, the closer you are to +1 or -1, that indicates the overall strength of a very strong relationship. Now also I want to remind you that R tells you two things about your relationship. It tells you the strength, like we just went over, but it also tells you the direction. Of course, the strength is implied by the absolute value of R, how close R is either to -1 or +1. But then the direction of your linear relationship is just given by the sign of R. If R is positive, then you have a positive relationship between your two variables, which means when you graph the line of best fit, you'll have a positive slope. If R has a negative sign, then that means you have a negative correlation between your two variables, which means when you graph the line of best fit, that will have a negative slope. Pretty simple. Here is the formula for R. Now, so far, when we've looked at R, we've just had the calculator output it for us when we've run our linear regression. But when the calculator is running that linear regression, this is the formula it is using to calculate R for you. I just want to point out a few pieces of this formula so you understand what it's saying. First of all, you'll notice this 1 over n minus 1 factor. Here, this is just n is the number of terms, or the number of data points that you're looking at. Notice again, we've got this sigma sign here. Remember that the uppercase sigma in mathematics simply represents addition. It means we're going to be adding a bunch of different things together. And those things that we're adding is given by this expression right here. This shouldn't look too terribly intimidating because it's got a form that's very familiar to us. Notice what each of these factors individually is saying. This first one here that I've just circled says we've got x sub I minus x bar over s sub x. Now what are each of those pieces? X sub I, right here, that's just each of your individual x values from your data set. X bar, of course, is the average or the mean of those values. And S sub x is, of course, the standard deviation of those x values. So this should look a little bit like our z-score formula. Remember, that was each of our x values minus the mean divided by the standard deviation. We've got the same form here. So that's what that first factor is with the x's. And then over here with the y's, the second factor has exactly the same form. It's just saying take each of your y values, subtract off the mean, and then divide by the standard deviation of y. So you do that for each of your pairs. So for each point, you're going to have an x value paired with a y value. You find essentially its z-score, multiply those two things together, and then you add them up for all of your points, and then divide by n minus 1, and that gives you your r value.